Hello, my name is Luciano Correia. I am a student in Master in Informatics Engineer and Information System in Polytechnic of Viseu, Portugal. And I'm here with my colleagues, Manuel Lopes and Carolina Ferreira. Unfortunately, she's not here with us by personal reasons. Meanwhile, to present you our work and scientific paper. This work has the objective, and we were invited by our teacher Pedro Martins to design and develop this mobile app inside the scope of this curricular unity named Information System for Mobile Devices. So in this context, we will start to present you EasyScan, the name of the application designed to this course, to this unity, curricular unity. And EasyScan stands 1 image, 1,000 words. EasyScan has as a main features the features present here, and we have the first one is save text from image online and offline way. Second one is the facility to copy quickly image contents to another app if we reuse that content in another app. So end user is able to get analytics from recognized text. In another context, we have the possibility to get the feeling and the intensity related with the text captured from the image. And the last one is related with discover what information types are implicit on the text.
So, hello everyone. I'm going to talk a bit more about the data architecture that we used in the development process. We used the MVVM architecture, model view model, in order to isolate the backend from the front end. As we see in this scheme, the user interacts with the activity or fragment components, which will be isolated from the data layer. The view model has the responsibility to convert and expose the data to the front-end components. The repository will access the database. This database is composed by cache and Firebase. The process of synchronization between these two components of the database is done automatically by Firebase, which has made very simpler the development process because of this characteristic of the Firebase. To save the documents, more specifically the images that we captured on the application, we use the Firebase storage, and to save all the information besides of that image, we use the Firestore. So, talking a bit more of the process of the text recognition and all the analytics that EasyScan provide, I'm going to talk and explain how the process is done. Firstly, the user can take the picture using the camera, or just upload an image that is saved on its gallery. Doing that, let's consider that the application is online. We're going to use the Cloud Functions component, which is a Google service which allow us to have some server actions, even not having a server and manage a server. So we take the image that has been uploaded to the application, send it to the text recognition API by ML Vision. Then we get the recognized text and save it on the cache. As I was saying before, we are on the online context, so the data is automatically synchronized with Firebase without the user noticed, and the information is saved. Now the image and text and direct analytics from the text, like words counts, lines, paragraphs, are saved into the online and offline. In the Cloud Functions, we have also a trigger that is triggered when a record is created or updated into Firestore. In this case, as we just created a record, this trigger will be triggered and called the Natural Language Processing API that will get the text that was saved and will show us some more analytics, like the sentiment and its intensity, as well as the information type. For example, if a text is related to arts or entertainment and the model has 99% of confidence that is related to that, the natural language API will give us that information to in order to show the user, and of course save it on the database. When user is offline, we use the text recognition model that is saved offline into the application itself. It is not a powerful model like the online, because the online model is always updating with new data, and so its predictions can be more reliable than the offline model. That's why we like to use as always as we can the online model. But if the user is offline, he will not notice much difference in the user experience. So using that offline model, we get the text recognized from the image and save it on the cache. Once the user goes online again, the data is synchronized with Firebase and the process is repeated. Like I was saying before, the NLP API is called again to get all analytics that I just talked about. So Luciano will talk more about the aspect and the UI of this application.
Thank you, Manuel, by your technical presentation about the architecture. And now we are speaking a little bit about the user interface implicit in this mobile application. So here we have 3 print screens of the mobile app EasyScan. And in the first one, we have the last scan applied by the end user, and some other functions as well. The log off, it is implicit in the top right corner, and in bottom of this print, we have the possibility to visit history of the works captured, and another two options, two different options. The first one is related to take a photo in real time, and another one the possibility to choose an image from the gallery of the mobile device that we are using EasyScan in that moment. In the second one, print screen, after capture or selected one image from the gallery, we are able, as an end user, we are able to choose another works that are present in this print screen, and we have the possibility to scroll down or scroll up to choose more conveniently. And the third one, the print screen, after select the work, the properly work in the last print screen, we have the text. In the first half of this print screen, we have the text and some features that end user can apply on that text as well. The copy to clipboard, the end user has some statistics information about the text, like the number of lines, like the number of words, and the language used in that text that is automatically captured from the text. At the bottom of this print screen, we are able to see the analyzed sentiment implicit in that text. And finally, we have the classification or confidence related with the sense of that text described in the image captured. As well, we have a float button that give the end user to end user the possibility to edit some translation that was not applied in an efficient way, and in the last point, if we have to clear the work, the present work, we have the possibility in the right top corner to clear all the text captured from the image.
Okay, it's important to refer that all these three screens are available both online and offline scenarios, and all the actions that Luciano has talked about are available in both scenarios as well. Something I would like to highlight is also that we challenge ourselves to implement and develop this application on Google's Universe, and we achieved that goal since the machine learning layer to database and cloud functions. We did all that using Google components, which was a goal that we defined early, and we could achieve it in a good way.
Totally agree with you, Manuel. And for all that are supporting this presentation, our thank you for your support and your time to assist this presentation. And with this work, we hope to give you our contribution in order to open ways to more specific scientific discoveries in this matter. If you have any functional or technical doubt related with development, please feel free to present them, and we are trying to clarify each one of them. Thank you.
Thank you.